Hello, and thank you for joining me today to talk about how IBM can help you manage your existing virtualization environment. Before I begin with the demonstration, I want to show the virtual environment that we'll be using in the rest of the demonstration. I realize that this is not going to be as complete or as complex as your real production environment might be, but the components are meant to be at least representative of what really exists in your environment. In going through this demonstration, I'd like to focus on some of the challenges you may be facing in your environment. When I talk about cloud optimization or cloud management, I like to break management into three categories: visibility, control, and automation. Just to give you a bit more of an idea of how I use those categories, I have a few examples. So for visibility, how many VMs, templates, storage pools, or other resources do I have, and how are they performing? What about my underlying physical infrastructure? Control. How do I control image sprawl and manage creating new images? How do I control what's in the images or what patches are installed on my images? And automation. How do I eliminate the manual tasks in my virtual environment? How do I create images, patch endpoints, perform trend analysis, capacity planning, and backups? And as you see from the diagram, all of these capabilities are designed to work around your existing virtual environment, so you can continue to use that today without any impact on the system. So let's begin by actually looking at the environment that we'll be working with. You can see in the vSphere client I have a data center defined with a single ESX server, two storage repositories, two virtual machines, and a virtual machine template. The virtual machine in the middle of the screen with the green arrow is the one that's running, and that's the virtual machine that we will use for the majority of our management activities. As mentioned, this is a small environment, but should be representative of your environment and will be more than sufficient to demonstrate the capabilities. So let's begin by talking about how we can monitor what's going on in this environment. To do so, I'm going to switch to the Tivoli integrated portal, and since we have a standalone server and not a cluster, I'm going to go to the standalone server dashboard. And immediately I get a good visualization of what is going on in my environment. In this top left panel, I can see a server scorecard, so if I had multiple ESX servers, I could very quickly see the health of each one of those. In this case, everything is green, showing that the resources are healthy. The rest of the diagram shows other visualization of the monitoring information for this particular server since it's selected. We can see key metrics like memory, CPU, and disk. If we want additional information about any one of these categories, we can get that by clicking the green check mark. In this view, we see the same two repositories that were defined in the vCenter, and in this case, we see that one of them has a green check, the other has a red X because it is almost full. If we want more details about any of this information, we can use Launch in Context to launch the Tivoli Enterprise portal to display that more detailed information. Here we see the Tivoli Enterprise portal where we can get a vast amount of information about the system. If I expand these categories, we can see we have the visibility into the entire virtualization infrastructure agent. So we see not only the data stores, but other information about the system. So this information gives us an idea of what's happening on a day-to-day basis. What if we want to use this data to project out into the future to assist with our capacity planning process? Smart Cloud Monitoring has this functionality built into the product out of the box. I'll return to the reporting section, and let's look at the workload performance trends and forecasting set of reports. I'll begin by the cluster performance trends. Now this chart here shows a very quick look into the environment of how our clusters are performing from a memory, CPU, and disk perspective. So very quickly I can see that this cluster is using more memory than many of the other clusters, so this may be something I need to accommodate for in my capacity planning. Another chart I'd like to show is a CPU heat chart. This chart gives a very quick view on a host-by-host basis of how our hosts are performing. And very easily, our eyes are drawn to the red section down here that says we need to look at this host more carefully to see what we can do to address this resource issue. We also have a set of reports that help plan out into the future, specifically if you know a certain workload is going to be added in the future. So perhaps we have a large deployment going on in a month, and we need to know, based on historic performance, what we would expect to need from a resource perspective. These reports here can get you that exact information. The last set of charts I want to look at are for balanced and unbalanced clusters. This is very powerful information. The hypervisor can move loads within a cluster, but it has no visibility into how big the clusters should really be. And this chart right here shows exactly that information. So with this report, we can see in orange that the memory utilization of our 64-bit cluster far exceeds that of our production cluster. We've seen how we can get visibility into our future resource needs and current resource utilization. Now let's take a look at one of the other operational aspects of dealing with the environment. After virtual machines start running in the environment, our users will likely begin to use them, and after time they may drift away from the original configuration, or perhaps new vulnerabilities will be discovered. Many customers need to be able to specify a security or patch policy and verify that it's followed. So what I'd like to look at next is how we can get visibility into these types of compliance issues. In many cases, we'll create baseline security standards that our endpoints need to follow, but to demonstrate this a little easier, we'll manually investigate an issue. To begin, I'll switch to our Security and Compliance Analytics dashboard. This dashboard shows at a very quick glance the health of our environment. We can very quickly see that our environment is 74% compliant. This may not be acceptable in a production environment, but for a demonstration, this gives us some flexibility to pick and choose several items to address. We can also check to see the history over time very quickly with this diagram right here, as well as the number of compliant or non-compliant issues at any given point in time. We can see currently that we have 65 non-compliant items. Before we go and address one of these items, I'd like to go ahead and take a backup, since this could be production or mission critical data, and we want to be able to restore that information should something occur. In order to take that backup, I'm going to switch to the vSphere client and use the built-in Tivoli Data Protection for VMware plugin to take that backup. In a production environment, this likely would be scheduled on a regular basis, but for the sake of the demonstration, I'd like to schedule it manually. We see the same tree that we would see natively in VMware, because again, this is built into the vSphere client. We have the ability to do an incremental or full backup, or a full backup followed by several incremental backups. This gives you the flexibility to restore to any of those points in time, but saves you on resources from a networking and storage perspective. We see that the TSM server has instructed VMware to take a snapshot, which will then allow it to take a point-in-time view of that virtual machine. We can see this takes just about a minute, and if I switch to the events view, we see that the demo backup was successful. So now that we have a backup, let's address one of those security issues that we saw in the previous dashboard. These checks are all based on checklists, which basically have prescribed checks to go out into the environment and verify different security aspects. These are based on that of DISA, the government organization. I'm going to search through the applicable checks, and we see that one of the options is for FTP user file permissions. So this check states that this particular file needs to have file permissions of 640 or more restrictive. If I go to my target machine and look at the actual file, we see that the file permissions on this file indeed are out of compliance. So what I will do is flip back to the interface and say I want to take action against this particular computer. In the case of file permissions, this would be a relatively easy fix to address by logging directly into the virtual machine. But if there were hundreds or thousands or tens of thousands of endpoints, that would not be scalable, nor would it be automatic. Which again, remember, we could create a baseline to automatically address this when it was detected in the environment. And now we see that the issue has been addressed. If I return to the window and recall the last command, we see that the file permissions were indeed changed. And again, this could be scaled across a very large environment. One other interesting piece to look at from a compliance perspective is patching. When I open the patch overview dashboard, we get again some very good visualization of what's going on in the environment. We see that my target endpoint is running SLES, and these are the biggest or most impactful patches that are missing in my environment. So if I launch the one for libxml2, we get the details of the package, the RPMs that are going to be required to address this issue, and just like with the security issue, I can take action against the relevant endpoints. This again can be rolled out to a large environment in a matter of minutes. We see here that the files that are required for this particular patch are being downloaded and have been cached on the server. And now the status has been changed to fix. So this patch has been applied to our target endpoint. This is just another one of the operational aspects that IBM can help you in managing your virtualization environment. If we return to the vSphere client again, I'd like to return to the map view. We see here that this is a very small environment, so it would be relatively easy to manage what's installed on these particular images. But how many images are installed in your environment? Do you know the content of what's installed on those images? Using the virtual image library component of Smart Cloud Provisioning, we can get details into those images even without them running. So let's take a look at that capability. I'm going to switch to the virtual image library, and what we can see is after we create the link to your hypervisor, which here we'll refer to as an operational repository, we can automatically discover all of the images and virtual templates that are out there. And this can work across different virtualization technologies as well. We're also able to index and get the details about the contents of the images. This allows us to easily see in a consolidated view what's running on all of our images and perhaps how we could cut down on the number of images or image masters that we need in our environment. Down the road, this can save us a lot of time on maintenance and patching. So if we look at this in a little more detail, we see that this is broken down into two main sections. We have our virtual image templates here, and we have an image template that's reflected in our hypervisor environment, as well as a reference image or master image that we can use to deploy across multiple environments. If I select this image, we get some general information about the image itself. We see that it's running SUSE Linux, we see that it's been fully indexed, and down here at the bottom we see the high scale low touch compatibility says not compatible. I'll talk more about that in just a second. We also have the ability to do version tracking, so we can see that this is how this particular image got to where it is. This is like doing source control for your virtual machine images. In the Installed Software tab, we can see all the different pieces of software that are installed on this particular virtual machine. On the High Scale Low Touch Compatibility Details tab, this is what tells us if this particular image could be used in another environment. In particular, what we're looking to do here is move resources from a higher cost hypervisor such as VMware to a lower cost hypervisor such as KVM using our HSLT technology. So we've seen we can find out details about a particular image. One other very powerful capability that we have is to compare this image to other images in our environment. So what we see here is how similar is this image to all the other images that we know about. This can be very powerful in trying to combat image sprawl. So in my demonstration environment, we can see that there are two other images that are identical to this particular image. This means if this was a real environment, I would probably want to take some action against this so that I didn't need to maintain three of the same images. We also see that this image is very close to it. If I'd like to see the details of what's different between this image and the other image, I can do that too. I'll start by clicking this image and selecting the compare action. I'll return to the original one and also select the compare action. Then we can see on a product and file basis what are the differences between these two images. From a product perspective, we see that there are two products installed on this image that are not on the other image, the ITM agent and the Tivoli Endpoint Manager agent. There's nothing on the reference image that isn't on the other image, and there is no software that's on both images but different. We could do the same comparison at a file-by-file level. Again, all of this without ever turning on the virtual machines. We can go out and index the information in the environment without affecting those virtual machines. The last piece that I would like to show is the search capability. If I return to the Images tab and bring up the search function, we can search on a number of different characteristics to find an image candidate to use in our environment. For example, I could say I only want Linux images, and these would show up. I could also say maybe I only want images with a particular piece of software. Perhaps I'm deploying a custom application that requires Perl, and I can search to find which images have Perl. Now there may be cases where we do a search of the virtual image library and discover that the ideal image that we need is not there. IBM also has capabilities in this space in the Smart Cloud Provisioning portfolio that allow you to build custom images based on baseline images. So what we can do is define our baseline images. So these images would have all our corporate security standards, all of our custom applications, basically our golden image for the environment. And what we can do is define that as an image. We can then also create a software bundle of one or more software products to apply to that image, and without ever touching the virtual machine environment, we can define this information once and use it over and over again. So we'll build our best practices into the images and into the software bundles and then reuse those assets. So let's take a look at that in a little more detail. If I go to the software bundles section and look at the management agents bundle, we can see that I've defined an agent that will install the TEM client and the ITM operating system agent. If desired, we could set specific requirements such as what operating system this is supposed to be installed on, or specific install binaries and install scripts. Once we've defined this software bundle, we can take this bundle and apply it against one of our images. So in my environment, I have two images defined, one for test and one for production. This represents my baseline or my master image for all of the environment. We can see that it's running SUSE Linux, and there really isn't much more installed on it right now. So what I would like to do is create a new image based on this baseline and attach the software bundle that I previously defined. So I'll create a copy of it, and I will edit my copy, add my software bundle, save the new image, and based on those software bundles, we now will install the TEM client and the ITM agent. In order to do this, we'll need to synchronize it into the environment though. So this is logically defined, and the next step in the process will take these images add in the software bundles based on the instructions we define, and create a brand new image. So I will say I want to synchronize it. And with a click of a button, I've just created a brand new image in the environment. Now this will take several minutes to synchronize, but it is very powerful, and you can see how quickly I could create a custom image if necessary. I hope you're as excited as I am about the capabilities I've shown you here today. I believe the visibility, control, and automation that IBM can bring to your existing virtualization environment without interfering with it can bring you immediate value. Thank you for your time, and I hope you enjoyed the presentation.